Welcome to my channel Start Study Score, and I am your teacher Shushmita, and we are going to start a very intimidating topic that is called magnetism. Now, what are magnets? We have started magnetism from early class 7 or year 7. We know what are magnets, how they work, how they don't work in certain circumstances. Yes, but at the same time, we have no clue how they are able to attract or repel some objects. Why it is so classified? Although it is grade 12 study, we are going to continue, but for basics, this is the basic video. I am doing a basics about magnets, so anybody can refer from year 7 to year 10. So what are magnets? Any object which is capable of producing magnetic field and attracting unlike poles and repelling like force. Well, it is a hint for you, although it is a kind of definition, but it is a hint for you. What do we understand from this? We understand that that particular object has a capability to attract certain objects like iron. You must have aware of it, like they are attracting iron, nickel, cobalt, and in some cases some alloys also, which we are going to discuss in near future. But for now, it is just an object. Now, magnets can be of two types, natural as well as artificial. How do they work? So for that, I will first discuss what is a natural magnet. Natural magnet is found naturally around the earth crust, okay, that we call as magnetite. Now, although it is called magnetite, there is a problem in it. The magnetite is naturally occurring. That means it should have a formula. It is the ore is called magnetite, but at the same time, what is the formula? We should be knowing. It is also called lodestone, and the compound is Fe3O4. Well, this is quite some knowledge we gained, but for now I will skip and go to discuss what are natural and artificial magnets and what is this attraction and repulsion at the same time from an object. Let's discuss. Now, what are the properties of a magnet? When we are talking about properties of a magnet, normally all the magnets will attract only ferromagnetic substances. But what are ferromagnetic substances then? Like iron, nickel, cobalt, and some alloys. Okay, now the property, there are many properties, but I want to highlight only two properties. The first property is called the attractive property. Now, by attract, what do we mean by attractive property? Now, you are looking at a picture which is very normal when we see them. The color code I have provided just to understand. So if there is one is North Pole and one is South Pole, they are bound to come closer, means they opposites attract. Okay, at the same time, if it is two poles are the same nature, then they will be like poles, and that's why they will be repelling each other. This is also called attractive property. So this particular one, the line here I have highlighted here, like poles attract, like pole repel, and unlike poles attract. This would be called attractive property. Okay, this would be called attractive property. Now, if we are taking a magnet which always, if it is suspended freely, it comes to rest in north-south direction, pointing the north, okay, towards the North Pole star, then it is called the directive property of a magnet. So this is called directive property. Now there is another thing, third property, all the poles of the magnet work in pairs. This is a very important point of a magnet. Work in pairs means what? So for that we have to go to many discussion, where I have written something here which I want to share with you. The properties of a magnet. Now in properties of magnet, you can see that I have written poles exist in pairs, meaning if I am taking a magnet having north and south, and if I am going to break it into two pieces, I am supposed to get a north and another south, different one, like this. But no, this doesn't happen. It breaks into two, and we will get two magnets of less magnetic strength, reduced or halved magnetic strength. So it will be two magnets having reduced magnetic strength. So we will always get, if I break a magnet into two, then I am bound to get two magnets. I am bound to get two magnets. This is one and this is two. These two will be also magnet. Now if I further divide it till I can, every point of time I am bound to get a magnet only. So the times you are breaking it down, the number of magnets you are getting. So this is the first learning. But I will also discuss attractive property. Attractive property I have written in the PPT, still I want to discuss it, because all the magnets will attract magnetic materials which are specifically ferromagnetic. Now it will also attract unlike poles of another magnet, meaning if it is a north pole we are looking at, then it will definitely attract a south pole. Now a south pole if we are taking, it will definitely attract a north pole. This is called attractive property of a magnet. Now what is directional property? Directional property is such that when it is if it is suspended from a string, or it is just kept as it is, like it is free to move, then it will always move towards, you can see I have shown it a little bit tilt towards some side. I have notified G, N and MS. What are they? Well, we are going to discuss. But before that, we need to be very clear that directional property suggests that every magnet will direct towards the north pole star, meaning the geographical north. So wherever you put the compass all around the globe in planet Earth, it is going to show the it will show towards north and south. Now this is a very interesting character, but at the same time it is creating a bigger confusion. Now that confusion I am going to address in the next class. What is the confusion? Confusion is, if the magnet has a directive property, if the magnet has an attractive property, how is it happening that the magnet is showing the north pole? It should be, that means that should be the magnetic south. Why we are calling it the north pole then? Then they are in contradiction, right? So I am going to address it in the next video. For now, I'll stick to the plan, and we will do this, the pole, what is called pole of a magnet. Now pole of a magnet is called where the maximum strength of a magnet can be seen. Now if I zoom a little bit, you can also see properly and note it down. So pole is denoted by M, small m, not capital, and it shows the maximum strength of the magnet, and it always exists in pair. That means if I have taken this magnet N and S, and the mid part, there will be no strength in the central part of the magnet. All the strength will be at the poles, the ends. One is notified as N, one is notified as S. N for north, S for south. Now you can see I have drawn a parallel line over here along the magnet, this one. Now this is called the magnetic axis. Okay, it is an imaginary axis just along the north and joining north, center and south. This is it. So that will be called the magnetic axis. Then what is magnetic meridian? Magnetic meridian, which is perpendicular to the magnetic axis. This one you can see. Yeah, so it is perpendicular to the magnetic axis. It is also a imaginary line, but it is perpendicular to the magnetic axis. So I am color coding it so that we are understanding it properly. Then what is magnetic length? Magnetic length is such that it is just the distance between north and south pole. That means the pole are little inside, they are not equal to the geometric length of the magnet, which I have denoted by G. You can see that I have written. Now G is the geometrical length. Now how if the magnet is of 10 centimeter, then the magnet is of 10 centimeter in geometrical length, but the magnetic length will be little bit more or less depending where the poles are situated within the magnet. So that we call as the 2L magnetic length. 2L. Then what is the magnetic moment? Now moment means torque. Moment, so that means the poles have a certain tendency to create a torque. We have learnt in laws of motion torque properly that force time distance. So that is definitely related to the magnetic length. What is magnetic length? 2L. What is the force that supposed to be there in the poles? We are taking individual. It can be N, it can be S. So I am taking only one M. M is a vector quantity because it has got a direction, although the magnetic length is a scalar quantity. But the magnetic moment, when multiplied, it is a vector quantity, M times 2L. Okay, you can see I have highlighted the vector notation just so that we remember that the pole strength is a vector quantity. Also the magnetic the magnetic moment is also vector quantity, capital M, and SI unit will be ampere meter square. Please note the magnetic moment, SI unit of magnetic moment will be ampere meter square. I hope this is it for today. In next video we shall meet and discuss why there is a contradiction between geographical north and magnetic north. Take care, have a good day.